You're saying you can't find under root thing on your calculator in the laptop? You can. So if you write calculator, are you using a Windows system or under root 2? 1.414213652, and if we check it further, it would keep going on and on and on, and there would be no end to the number of digits that I get after the decimals. So such numbers which are not completely solved, such numbers, they are called irrational numbers. So we discussed pi is an example of that. Root 2 is an example of that. 1 divided by root 2. Mm, that would also be an example of that. So such irrational numbers, there is no end to solving them. So we have discussed natural numbers, the numbers which begin with 1 2 3 4 5 and they go on up to infinity. We have discussed whole numbers, natural numbers plus 0. So 0 1 2 3 4 5 and onwards till infinity. We have discussed integers which are 0 and to positive infinity and backwards to negative infinity. We have discussed rational numbers, we have discussed irrational numbers. Acha ji, the other types of numbers that we would commonly encounter, so for example, even numbers. What are even numbers? Ji, Arman sir. Hmm. Very good. So numbers which are divisible by 2. And what are odd numbers, Miss Aisha? What's the first odd number? 1. What's the first even number? The first even number would be 0. Okay. Let me confirm first even number. Yes, that would be 0. So 0, 2, 4, 6, 8, and onwards. These are even numbers. 1, 3, 5, 7, 9, and onwards. These are odd numbers. Then there is a term that we'll soon be using. Types of numbers which are called prime numbers. Miss Aisha, what are prime numbers? Ji, Sir Arman. But there must be some rule. So numbers which are divisible by 2, those we called even numbers. The numbers which aren't divisible by 2, we call them odd numbers. Okay. So how do we define, what's the defining criteria of prime numbers? Okay. Sir Arman, what's a prime number? Excellent. A number that is divisible just by itself or 1. So examples of prime numbers are 1, 3, 5, 7, 11, 13, and then onwards. So there isn't a fixed criteria. So for example, if I have any even number and I want to get to the next even number after that, I will simply add 2 to it. If I have got any odd number and I want to get to the next odd number, I would simply add 2 to it. But there is no fixed criteria for prime numbers that I can get them by adding, multiplying, or dividing something. They're just there and I have to find them out. And the criteria is that these are the numbers which are divisible just by themselves or by 1. Okay. अच्छा जी. अच्छा जी, all the rational and irrational numbers combined together, they are called real numbers. All the rational and irrational numbers, if I gather all the rational, and by the way, if I write 7 over 1, would it be a rational number or not? Ji, Arman sab, 7 over 1, is it a rational number or not? It would be a rational number. Any number that is expressed in the form of ratio and there is a definite answer to it, there is no indefinite answer to it, that would be a rational numbers. So for example, I write 6 over 2, it would be a rational number. I write 18 over 9, that would be a rational number. So all the rational and irrational numbers, if I combine them, they give me the set of these rational and irrational numbers combined together, they give me real numbers. What are imaginary numbers? That is, so the opposite of real numbers is imaginary numbers, and that is something that would pop up later in the topics of maths when we are especially doing the square roots. So I will discuss that over there, but you can write it down somewhere in the margins of your notebook that the opposite of real numbers are imaginary numbers. And what are exactly imaginary numbers, that's something that we'll discuss later on. Acha ji, we have discussed prime numbers, we have discussed rational, irrational numbers. Next thing that we have is a reciprocal of a number. So, how do I find a reciprocal of a number? Reciprocal. The reciprocal of a number is every number when it multiplies with its reciprocal, it gives me 1. So for every number, what is the number that I have to multiply it with so that I get 1? That would be the reciprocal of that number. Did you both get it? So for example, if I have got 1 over 5, what would be the reciprocal of 1 over 5? Ji Arman sir? 5 over 1. Excellent. Or simply 5. Similarly, if I have got 22 by 3, what would be the reciprocal of that, Miss Aisha? 3 by 22. Okay. Acha, let's do just one more example. If I've got 2 whole 7 over 3. No, 2 whole 2 over 3, let's say. 2 whole 2 over 3. G, what would be the reciprocal of it? Arman sir? 2 whole 2 by 3. 3 over 8. Excellent. Excellent. So first I'll convert this compound fraction into improper fraction, so it becomes 3 to the 6 plus 2 8, 8 by 3. So the reciprocal of it would be 3 over 8. Excellent. The next thing that we have to know is that there is a concept of factors and multiples. There is a concept of factors and multiples. What are factors and multiples? Does anyone of you know? G. Arman sir, do you know what are factors or multiples? Excellent. 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 Excellent, excellent, excellent. So factors, Sir Arman, he just told us that factors are the numbers that would multiply to give me a particular number. So for example, he said that 6, the factors would be 2 and 3. One more thing we have to remember that 1 is factor of every particular number because I can multiply 1 with that particular number to get that number. So 1 is factor of all the numbers. Let's see a few more examples of factors. So if I asked you to list down factors of 12, Miss Aisha, can you tell me what would be the factors of 12? 1, 2, 3, 4, 6, and 12. Excellent, 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 Ji. Acha, and what would be the multiples, Miss Aisha? If these are factors, then what are multiples of a number? Mhm. Multiples are the numbers that I get if I multiply a number with anything. So for example, the same number, if I take 12, what are the multiples of 12? The first multiple will be 12 itself, then 24, then 36, then 48, and onwards. So these are multiples. Okay, that's the difference between factors and multiples, and soon we would be using this piece of information. Okay, so the first number that this thing's quite easy, this thing's quite easy. Okay, the next thing that we have to do is, let me give you a few numbers and I'll ask you to write down factors of that. So the first number is 42. If you could both please on your own notebooks write down factors of 42, and then once you have done that, please text that in the meeting chat box. Yes, sir. Dear answer. Correct. Very good. अच्छा, Miss Aisha, you missed out one. ठीक है जी. So the way to do it is that 1 would be a factor of every number and 42 would be a factor of every number. Then we'll have to check for 2 if 2 is or not. If 2 is, then 42 divided by 2 is what? 21. So automatically I know 21 is also a factor. Similarly, I check for 3. Is 3 a factor? Yes. If 3 is a factor, then some other number, this divided by 42 divided by 3, that gives me 14. 14 will also be a factor. Then I check for 4. It's not 5, it's not 6, it is, and 6 and 7. So that would give me all of the factors of this number. Other than finding factors of a number, another task that we have to do is to find out the prime factors of that number. So what are the prime factors? Among all the factors that I get, what are the prime numbers? So for example, out of these factors of 42, what are the prime factors of 42? 1, 2, 3, and 7. These would be the prime factors. Yes. ठीक है जी. अच्छा, another exercise, another way we do it is, so for example, if I give you 35 and I ask you to list out the factors of 35 or the prime factors of 35, the way we do it is we try to divide it with the smallest prime number beginning with 2. Is 35 divisible by 2? No. Is 35 divisible by 3? Yes. So 3. 3, no, it's not divisible by 3. So the smallest number would be 5. 5. 5. 5 sevens are 35, and then 7 ones are 7 and 1. So the prime factors that we get are 5, 7, and 1. Okay. Similarly, if I give you a number 70 and I asked you to break 70 down into its prime factors, the way we would do that is, 2 3s are 6, 35, 5 3s are 35, sorry, 5 7s are 35, and 7 1s are 7. Okay, ji. So the prime factors for this would be 2 into 5 into 7 into 1. Acha ji, let me give you another number. ठीक है जी, we have found the prime factors. The next thing, once we have found the prime factors of some number, the next thing that we have to do is, once we know how to do that, we can, using the prime factors of a number, find out the HCF and the LCM of a number. Okay, have you people done this before? Miss Aisha, have you found the HCF of numbers before? ठीक है. And Arman sab, you also know how to do it? ठीक है जी. So the numbers, let's begin with easy one. So I give you 10 and 25. How can I find the uh, HCF of 10 and 25? If you could both please give it an attempt and let me know what's the answers that you're getting. जी 10 and 25. HCF of 10 and 25. Amansa, what's the answer that you're getting? I just told you to find out HCF of 10 and 25. Miss Aisha, are you sure it's 25? Hmm. Okay. Acha ji, the next number that we have is 22 and 110. What's the HCF? Yes, G22 would be the answer of HCF for 22 and 110. Let me see. Okay, 60 and 144. This would be the last for HCF, 60 and 144. Ji, Miss Aisha, do you have the answer for this one? HCF of 60 and 144. Or are you still solving it? Ji Arman sir, can you tell me how we do this one? How did you get that answer? It is. We are finding HCF, yes. And your answer that you mentioned is 16, right? Hmm, not correct. 60 and 144. You did for 16 and 144. Please redo it. Miss Aisha, is this the method that you follow that you find out factors, the prime factors? Sir Arman is saying 12. Okay. How, sir? How 12? This isn't HCF. How do you do it? How did you get this answer? That's what I'm more interested in. Okay, and then so once you get these factors, what's the next step that you do? Multiply, multiply. Okay, okay. Which numbers do you multiply? So all the numbers that are, so for example, you have 2 to the power 2 squared and 2 4. It is there in both of them. So I will choose the smaller one. 3 and 3 squared. It's there in both of them. So I'll choose the one with the smaller power. And 5 and 5 to the power 0. Again, I will choose the smaller one. Do you know where I got this 5 to the power 0 from? Any number raised to the power 0 is 1. Any number raised to the power 0 is 1. So for HCF, what we are trying to do is we are trying to find out factors which are there in both of them. So for 60, I got 2 to the power 2 into 3 into 5. For 144 also, I got the factors in the form of 2 and 3, but 5 was missing. So I could write a 5 with the power 0, right? And now I can compare all the numbers. 2 is there in both of them. I'll choose the one with the smaller power, 2 the power 2 to the power 2. 3, it's there in both of them. I'll choose the smaller one, 3 to the power 1. So that gives me 2 to the power 2, 2 to the power 2 into 3 to the power 1 into 5 to the power 0, and that gives me 12. This is how I found the HCF to be 12. Okay. Acha ji. Let's do LCM now. So for same 60 and 144, if I have to find the LCM, what would be the LCM? 60 and 144. So the same factors, the factors of both numbers, they have already been calculated. Now if so for HCF, I know I compare the two and I choose the number with I choose the one with the smaller power and I multiply those factors, right? The same way but for the LCM, for HCF, we took the smaller power. Now for LCM, what we'll do is we'll take the bigger power. So now if I compare these two, 2 to the power 2 and 2 to the power 4, which one is bigger? 2 to the power 4. So I take 2 to the power 4. Then I compare 3 and 3 squared. Which one has bigger power? 3 squared. So I write 3 squared. And then I compare 5 and 5 to the power 0. Which one is bigger? 5 to the power 0. So I choose these. Sorry, 5 to the power 1. 5 to the power 1 is bigger, so I write that. So 2 to the power 4 into 3 squared into 5, that gives me 720. So 720 will be the LCM. You got it, Miss Aisha? अच्छा जी 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 अच्छा जी. So once you have done this, now I would give you three numbers. Those three numbers are 25, 40 and 100, and you have to find both HCF and LCM. So the same way we have got the common factors in both of them. For HCF, we take the factor with the least power. Okay, the common factor which there in both of them, but the one with least power. For LCM, we take the common factor that's common in all of the numbers, but with the biggest power. So when we were doing HCF, we took 5 to the power 1 and 2 to the power 0, because the smallest power of 5 was 1 and the smallest power common between the two, it was 0, right? No, HCF would be 5, Arman. Miss Aisha, HCF would be 5, because for 25, it is 2 to the power 0. There isn't a 2 in 25. Yes, HCF would be 5. And for LCM, I compare the three numbers, I take the biggest power. So for this one, it is 2, the highest power for 5, and the highest power for 2 is 3. That is common in all three of them. Dear answer, we are getting the same answer for LCM. Miss Aisha, you understood how we did it? All right. Let's practice one more question. Let's say 6, 10, and 16. 6, 10, and 16. Sorry. The question, you have to find the HCF and LCM of 2, 10, sorry, 6, 10, and 16. You have to find both HCF and LCM. Arman sir, you got the answer? Correct. LCM is what? You're trying? Oh, okay, okay, okay. 240. Ji Arman sir, you got it? Actually, once you solve this question, both of you, the next topic that I would like to do with you is that of exponents and powers. Shall we start that today or in the next class? What do you say? Mhm. Next class. Acha. Dear Mansab, you got the answer for this one? G, G. So see, when I get the factors of 6, I get 2 into 3, right? Right, sir? Similarly, when I get for factors of 10, I get 2 into 5. So I just write 3 to the power 0 just in order to make the factors the same, and I write 5 to the power 0 in the first one just in order to make the factors the same. When I go for the factors of 16, I get 2 to the power 4 into, there is, I mean, that's it, 2 to the power 4. So just for the sake of confirmation, so that the factors, they are the same for all three of them, I add 3 to the power 0 and 5 to the power 0. So once I've got the same factors for all three of them, now in order to find the HCF, I will take the pair and I will take the number with the least power. So 5 to the power 0 is least. I take 5 to the power 0. Then I compare for 3. For 1, it is 3 to the power 1. For the next, it's 3 to the power 0, 3 to the power 0. So the smallest is 3 to the power 0. So I take 3 to the power 0. And when I get to 2, the smallest power of 2 is 1. So I take 2 to the power 1. So that gives me HCF as 2. Got it, sir? And the same for LCM. Only this time I have to take bigger powers. So out of power 0, 1 and 0, 1 is the biggest power. So I take 5 to the power 1. Then for 3, powers are 1, 0, 0. I take the power 1 since that's the biggest. 3. And then for 2, 1, 1 and 4. 4 is the biggest power, so I take 2 to the power 4. So 5 into 3 into 2 to the power 4, that gives me 240. Okay, sir? Acha ji, Miss Aisha, let's just keep it till here for today because the next topic, if we start right now, it has some explanation. I won't be able to wrap it up in time. So next class, inshallah, we'll try to do it. I request you both to please join classes sharp on time so that the 5 to 10 minutes that usually get wasted at start of the class, we are able to save that time. Okay? All. Oh, okay. 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 Chale, as soon as you're able to join, as soon as you're able to join. Obviously, I wait for most of you to join and only then I start the lesson. So, all right. See you in the next class then. All right. Assalamu alaikum. Bye.